All right, and we are going to explain now the microbiome composition, both at the phylum and the family level, the very end of our report.
Yeah, so we're back, and let me share my screen, pull up the report again. Okay, you can see it?
We can.
Okay, here's the important thing to note. This is an appendix. This is an appendix to everything else that's already been reported in the report, right? This is just another way of visualizing the report, or the report and the data and the overall ecosystem of the gut and how it maps against the U.S. healthy normals. So there's a bunch of different types of plots here. So this is called a donut plot. What's important about the donut plot is it's easy to visualize based on colors of how similar you are or dissimilar you are or your patient is to the U.S. healthy population. So this one looks, for example, at the phylum level for the U.S. healthy population. Here are the big main phyla: Bacteroidetes, Firmicutes, Proteobacteria make up basically 98% of all the bacteria, and others are just clustered as others. There's 3 others. But they make up such small percentage that, you know, it'd be very hard to visualize them on this donut plot. So when you're looking at the donut plot, you see that the U.S. healthy population tends to have really high Bacteroidetes levels, smaller Firmicutes levels, and you could see the relative abundance. About 71% of the total population of their microbes tends to be Bacteroidetes. About, 25% or so Firmicutes, and then smaller percentages for the other 2. Then you immediately look at your sample and you go, oh, okay, you could see just by visualization color that this individual tends to have a higher amount of Firmicutes than Bacteroidetes. Now, if you go back and you look at the Firmicutes-Bacteroides ratio thing, what you tend to find is that people with higher Firmicutes tend to struggle with weight. So this may be something that this person struggles with. This is an actual report, and I don't know the demographics and specifics on this patient. I just kind of pulled a random actual report, but that would be a guess, is that this person, because of their higher ratio of Firmicutes, tends to struggle with weight issues. And so you could see here the difference. And then this person also tends to have higher levels of Actinobacter. And if you look back in the report, there is a Proteobacter-Actinobacter ratio that we look at as well. This person tends to clearly have way more Actinobacter than Proteobacter. That part of the report explains what this means. This is just a color visualization of the same data, right? And it depends on some people. They see this and it's more visual, more telling to them. Others can look at ratios and numbers and it's equally telling to them. So this is just an appendix where you can kind of scroll back to the back and show your patient visually how things fall. Now, when you look at this plot, again, this is where, assuming the middle range is where each of these particular phylum, your U.S. healthy population would kind of fall here down the middle. This shows you where this person is on each of the phyla. They, they tend to be high here on the Actinobacter, which is represented here. They tend to be lower on the Bacteroidetes compared to the typical population, high on the Firmicutes. So again, it's the same data, just visualized differently. This is the exact same data, but they're giving you actual numbers here for each with the range of where the healthy population is. And then the second page of this is visualization, but down another level to the family level, right? So you've got the phylum level up there, which is the first page I showed you, which is the biggest groupings of bacteria. Now you get more specific into the family level of bacteria. Again, it's a donut plot to give you immediate visualization that go, wait a minute, in the healthy population, I've got a little bit of green, a little bit of purple, a little bit of brown, and a lot of this kind of lighter purple color. In this sample, I've got a lot more green, a lot more brown, and a little bit of lighter purple and more of this darker purple. Then you go here and you look at what those families of bacteria that tend to be prevalent in this individual. Now, those families of bacteria may represent biologically important bacteria, may represent higher levels of certain keystone strains, and those have all been talked about in the previous part of the report. This just gives you a visualization of the way to look at it. One of the questions that we had gotten before is, instead of the family level, why not the genus level or even the species level? Well, the problem is, even at the family level, we've got, what, about 10 different family. And even that, this part of the chart, as you can see, is already getting crowded. Imagine if we went to the genus level and there were 100, or we went to the species level and there were 400. That means we'd have to have little tiny slices of each of this part of this donut plot to represent each species or each genus in there, and it'd just be too messy to look at, right? So that's what this represents. It's just another way of visualizing, just like in the phylum level, visualize where the normal healthy population would fall, where this individual falls with each family of bacteria. And again, this is just for visualization. You're not going to look at this and make any significant interpretations. All of the interpretations were already done in the beginning part of the report. So this part is just an appendix, an additional way of looking at the data.